Have you ever wondered why artificial intelligence can hallucinate a completely wrong answer, but deliver it to you with the absolute confidence of a seasoned expert? We're constantly told it's just a software glitch, right? Just a temporary hiccup on the inevitable road to superintelligence. But what if the real problem isn't in the code at all? What if the mystery of why AI hallucinates with such confidence is actually hiding deep within the physical computer hardware, rooted in this fascinating, mathematically unsolvable issue known as the pink elephant problem? Welcome to today's Explainer. We're going to expose the hidden mechanics of modern computing and reveal exactly why true forensic accountability in AI means we have to look right past those user-friendly interfaces and get straight down to the bare metal. Okay, let's dive into this, because this quote right here perfectly captures the sheer frustration we have with the massive AI platforms we interact with every single day. Modern large language models, or LLMs, are essentially designed to act like omniscient deities. When they make a mistake, their underlying architecture actually encourages them to cover it up, to just sweep the error under the rug to maintain this perfectly polished jack-of-all-trades illusion. But if you scratch just under the surface, well, it's a completely different story. So here's our roadmap for the Explainer today. We'll start with the jack-of-all-trades AI, move into peripheral vision versus focus, then tackle the core pink elephant problem. After that, we'll look at mixers and fax machines, and finally, we'll wrap up with a post-mortem solution. Let's jump right in. All right, Section 1, the jack-of-all-trades AI. Let's break down this grand illusion. What's absolutely wild here is that understanding this definition completely shatters the illusion. An AI isn't an all-knowing digital brain. Not at all. An LLM is actually just a massive data compression tool. Think about it. It takes an unimaginably vast amount of the world's knowledge and just squishes it down into a tiny footprint using statistical methods. It's not pulling from a hard database of absolute facts. It's generating a statistical approximation, a facsimile of reality. Imagine slapping a fisheye lens on a camera to capture a huge 360-degree view. You get absolutely everything in the frame, sure, but as a result, absolutely nothing is perfectly in focus. Moving on to Section 2, peripheral vision versus focus. This is where we look at the hardware itself. Meet the real culprits hiding inside your computer chips, the FPU, or floating point unit, and the NPU, the neural processing unit. These are physical hardware components built from the ground up to prioritize blinding speed and massive parallel throughput over exact precision. And they pull this off by using what's called non-deterministic lossy math. See, because they have to process infinite numbers, like the square root of 2, within a finite physical system, they literally have to use rounding. And in these systems, rounding isn't just some minor glitch. It is the fundamental rule that defines the entire architecture. They aren't calculating exact truths. They're guessing, just incredibly fast. And this brilliantly illustrates the core divide in modern computing. On one side, we have the NPUs and FPUs. They act entirely as your peripheral vision. They are fantastic for noticing broad movements out of the corner of your eye, super fast, highly parallel, but fundamentally blurry. Then on the other side, we have the ALU, or arithmetic logic unit. This is your forensic focus. Sure, it might be slower, but it represents exact 1 + 1 = 2, fully traceable deterministic math. The problem? Current AI relies almost entirely on that blurry peripheral vision to do everything. Which brings us to Section 3, the pink elephant problem. What happens when we try to correct these blurry systems? So here is how the pink elephant problem actually plays out. Step 1, your data enters the FPU. Step 2, that information gets compressed using the lossy statistical approximation we were just talking about. But step 3 is where the danger really lies. Because the math used to compress the data involves all that rounding and lost decimal points, the data becomes permanently baked into the system. You literally cannot reverse engineer the math to find out exactly how a specific conclusion was reached. It is completely forensically untraceable. So the crucial takeaway is this: you cannot unthink the pink elephant. If you tell an AI to completely forget a specific piece of copyrighted data or a harmful instruction, it is virtually impossible to surgically prune it out of there. The memory is totally stuck. Because the FPU uses approximations, trying to force an AI to precisely forget one specific detail is exactly like trying to unstir sugar from your coffee. Let's look at Section 4, mixers and fax machines, to see how this degradation compounds. Lossy computing fundamentally fails when we need precision, because it acts exactly like a kitchen mixer. You know a cake came out the other end, but you obviously can't backtrack the math to isolate the specific grain of flour that caused an issue, right? It also functions kind of like a fax of a fax. Every single time the AI runs a cycle, it loses a tiny, minuscule bit of precision. Over millions of cycles, those tiny rounding errors compound into massive hallucinations. So you're probably wondering, why do tech companies keep using this setup? Well, just look at the trade-offs. We have the reliable surveyor, the ALU. It's highly exact, it's fully traceable, but it comes with a massive initial cost in terms of computing time and energy. Then we have the gambler, the FPU. It's approximate, totally untraceable, but it is incredibly cheap and blindingly fast. In the high-stakes race to completely dominate the AI market, speed and cheap throughput have basically won out over accuracy and accountability.
And finally, Section 5, the post-mortem solution. Let's talk about how to fix this mess.
Look, if we want true forensic accountability, we absolutely have to demand systems that allow for post-mortem analysis, not just clever algorithmic cover-ups. When an AI makes a critical mistake, we need the mathematical ability to freeze the system, look right at the code, and trace the exact deterministic steps that led to the error. You simply cannot do a post-mortem on a statistical guess. And why does all this matter right now? Because the stakes are moving out of your little chatbot window and into the physical world. We are talking about severe legal liability and fiduciary duties. We're talking about the medical industry and commercial flight. This even extends into robotics and target tracking. Imagine a robotic security system trying to identify if a fast-moving shape is a harmless mouse or a human being. We absolutely cannot rely on the blurry peripheral vision of a lossy, gambling FPU to make that final, lethal calculation. Determinism in these fields is totally non-negotiable. The solution here lies in stripping away the legal fiction of AI and getting straight down to the bare wire. In computer science, there's something called a PID, or process ID. It's a unique identifier given to every single computer process. Achieving true accountability means building deterministic systems where every single action an AI takes can be forensically tracked back to a specific PID, running on a specific physical machine in the real world. No more hiding behind the cloud. Because the truth is, risk is an aspect of reality. We really shouldn't try to infantilize society with fuzzy software guardrails that just attempt to hide the physical risks from users. Instead, we need to build physically accountable hardware from the start so that we can actually understand accountability and enforce mature culpability when things inevitably go wrong. Which leaves us with one massive, vital question to ponder. As these systems are integrated into the most critical aspects of our society, when an AI makes a high-stakes mistake, who do we actually hold accountable? The machine itself, or the non-deterministic math that was literally designed to permanently hide the evidence? It's a question we absolutely have to answer before the pink elephant gets completely out of control. Thanks so much for joining me on this explainer, and keep questioning the systems that run our world.